All right, here are the notes for Unit 7, Lesson 2. However, I just realized I skipped something in Lesson 1. So in Lesson 1, they have or in your notes packet, you have the key concept, solutions or substances that dissolve most readily in water, and then it has a blank for using the phrase likes dissolve likes. So in Lesson 1, we talked about polar and nonpolar substances. Polar substances have a partial charge, nonpolar substances do not. So the phrase likes dissolve likes mean that substances or solutions that are similar are going to dissolve in other similar substances. So polar substances will only dissolve in other polar substances. Nonpolar substances will only dissolve in nonpolar substances. So they have to have the same polar properties. The only exception is since polar substances have a positive and negative charge, ionic substances, which are made of a metal and a nonmetal, which is a positive and a negative charge, since both of those substances have some sort of a charge, ionic substances will dissolve in polar substances. So the things that you should remember is that water is a polar substance. So if you can remember that, then you can apply the likes dissolve likes. So make sure that that gets added, to the key concept for Lesson 1. The other thing at the bottom of page 1 of your notes, it has a line or information about electrolytes. We are actually going to skip electrolytes, so that bottom part with electrolytes you can skip over. So Lesson 2 notes would start on the top of the second page with solution, suspension, and colloid. So Lesson 2 will cover types of mixtures and talk about the differences between solutions, suspensions, and colloids. So a solution, when you're using the term solution is a homogeneous mixture. Homogeneous means it's all the same. So if you look at a solution, you can't see the different parts. So like Gatorade, if you have a bottle of Gatorade, you can't see the sugar and the dye and the water, you just see one uniform substance. So that is a homogeneous mixture in which all the solute dissolves. So in Gatorade, all of the sugar dissolves. There's no sugar left on the bottom. Same with salt water. Now you can put so much salt in that you no longer have a solution, but as long as all of the salt dissolves, then that would be considered a solution. So solution has the smallest particles, so as far as size-wise, solution has the smallest particles, so that's what this picture shows. All right, a suspension. So suspension means something is suspended on the bottom. So suspension is a heterogeneous mixture. So hetero means different. So you can see the different parts. So the large particles, suspension has the largest particles of the three, will settle out and you can easily filter them out. So sand and water would be an example. Another example would be like Italian dressing. When you buy it at the store, all those spices fall to the bottom and you have to shake it up before you put it on your food. So that would be another example of a suspension. And last but not least is a colloid. So colloid is also a heterogeneous mixture, so you can see the different parts of it. Colloid has medium-sized particles. So as far as particle size goes, solution is the smallest, then colloid, then suspension. So the particles are not dissolved, but they are evenly distributed, so they don't fall to the bottom. So milk, the fat particles are the particles that don't dissolve, but they're evenly distributed. So when you pour a glass of milk, you don't have to shake it up first. Fog is also a colloid. So here's a picture, again, in order of the particle size with some examples at the top. So you have the salt water in the fish tank. The salt is all dissolved. A colloid would be the milk, which is in the middle. It's got those fat particles that don't dissolve, but they are evenly distributed. And then mud, of course, would be a suspension. So those heavier particles would fall to the bottom. That's it for Lesson 2 notes.